Hello students, in this video you will learn about describing motion. Topics to be covered are what is motion, what is reference point, displacement versus distance, uniform and non-uniform motion, what is average speed, velocity, average velocity, and together with that we will be solving numerical problems. So I want you all to make notes with me and solve the numerical problem. So what are you waiting for? Grab your notebooks and pen, let's begin.
What is motion? An object is said to be in motion when its position changes with time. In everyday life, we see some objects at rest and others in motion. Birds fly, fish swim, and blood flows. From atoms to galaxies, everything is in constant motion. What is relative motion? An object may appear to be moving for one person and stationary for some other person. Motion depends on the observer. Trees move for bus passengers but are still for roadside observers. Different type of motions. Motions can be in straight line called linear motion, circular, rotational or vibratory, often in complex combinations. The distance and direction of the object with respect to the reference point at any instant of time describes the position of the object at that instant of time. So we need a reference point. So when do we say that object is in motion? If the position of the object with respect to reference point is changing with time, then the object is said to be in motion. When do we say the object is at rest? The object is said to be at rest if its position with respect to the reference point does not change with time. What is an instant of time? An instant of time is a single reading of clock at a given point of time. Let's say it's 4 o'clock. That's the instant of time. A time interval. A time interval is the time duration between two instants of time. That is between two readings of a clock. Let's say between 2 o'clock to 3 o'clock. It's 1 hour. That's time interval. Scalars and vector quantities, very important topics in terms in physics. Physical quantities which can be specified by just their numerical values only having magnitude are called scalar quantities, and physical quantities which require specifying both the direction and the numerical value or the magnitude are called the vector quantities. So we would be using all these terms to study and solve our numerical, students, right? Now, how do we describe a motion? That is what I said in the last slide also, that we need a reference point. So to describe the location of an object, a reference point is specified. So here we have taken an example. Let's say the railway station is the reference point, and if the school in the village is 2 kilometer north. So here we have given the directions for your reference. So if the school in a village is 2 kilometer north of the railway station, the position of the school is specified with respect to the railway station. So railway station is the reference point here. To describe the position of an object, we need reference point, which we also called as origin. So the school is 2 kilometers north to the railway station. So if you reach railway station, you have to move 2 kilometers towards north. Let's talk about motion along a straight line. So simplest type of motion it is. Here it is given that from 0 to 60 kilometer one number line is drawn to you. So let's think of it and study what it is. Now distance is what? The total distance covered by an object while moving. It is a scalar quantity and it has only magnitude. So let's see over here. Let's say an object or a person moves from O to A. So how much distance this person will travel? The distance is 60 kilometer, right? And then it goes from A to O again. Okay, first here and then here. So it will be 60 plus 60. That will be how much? 120 kilometer. Now to understand displacement, displacement is the shortest distance measured from the initial to the final position of an object and is known as displacement. It is a net change in position of an object between two given instants of time. So net change, let's say it started from here coming back here only. This is the initial position, right? And this is also the final position of this object. So it's going from O to A coming back to O. So initial position and final are same. So displacement will be 60 kilometer plus minus 60 kilometer, as displacement is a vector quantity. It has both magnitude and direction. So what will happen? Is it coming back? So direction becomes opposite. So we'll take it as minus 60. So it becomes 0 kilometer. So what you see over here, that the distance is 120 kilometer. It is a total path traveled by an object, right? And displacement is the shortest distance. So that becomes 0 over here. Now let's say the object moved from O to A. Then we have to calculate the distance and displacement. That will be same 60 kilometer, because in a straight line, the total distance traveled and the magnitude of displacement are both equal, because it is not changing its direction and coming back here. Now, displacement can be 0, which we got here. It can be less than or equal to distance, but it cannot be more than the distance. Okay. SI unit of both distance and displacement is meter. Now you would have seen in your automobiles, in the car or scooter or scooty or bike, there is a device that tells you the speed also, and that tells you make like kind of this thing is being made in which the numbers are written and you can see the distance traveled. Yeah. So odometer is a device in the automobiles to show the distance traveled. Speedometer is also around it like this, and which tells the speed in kilometer per hour. In between that you can see the distance traveled is also written over there. Okay, so this is what is distance and displacement. Now let's watch this video over here, which will talk about differentiate between distance and displacement.
Distance versus displacement. Walk two sides of a 10-meter square. Your distance covered is 20 meters. But displacement is the direct shortcut.
So here if you see the distance from this point to this point, so 10 plus 10, it's only 20 meter. And the shortest distance, let me name it as A to B. And if it is A to B, so shortest distance, that's the displacement, as it is a square, right? So this is the hypotenuse if it is 90-degree angle. So hypotenuse will be equals to square root of 10 square plus 10 square. And you know 10 square is 100 plus 100, correct? So 200 का square root will be 2 root 2 into 10. Root 2 का value I can take 1.414 into 10. So it changes to 14.14 meter. I hope this is clear, students. So how you calculate it? Let's solve few questions related to distance and displacement. Now an object has moved through a distance. Can it have a zero displacement? Yes. We just studied that in a motion, when an object initial and final position are same, then the displacement is zero. If yes, you can support your answer with an example, you can give it, right? When the initial and final positions are same, the displacement will be zero. Now, a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? I think almost a similar example, but here time is given, so you need to check how many rounds it is making, right? So number of rounds, how do you understand that? First let's draw a rough figure, a rough square I'm drawing here. So you have a 10 meter square field, and a farmer moves along the boundary of this field in 40 seconds. So one time 40 seconds, so one round is 40 seconds, and total time you have been given, so you say total time divided by time taken for one round of the square field. So total time is 2 minutes 20 seconds, and this much is 40 seconds. So convert 2 minutes into seconds. So 2 minutes will be how much? 60, 60, 120. 120 plus 20 is 140. So 140 by 40, which is 7 by 2, which is 3.5 rounds, right? So how many rounds are here? 3.5 rounds. So let's say the person starts from here. So one round completed till here, second round, then the third round, and then only the half round more. So yahan se it will go. Understood? So first round, I repeat, then the second round, then the third round, and then half round till here. So final initial position is this, and the final position is this. So how do you get the displacement? Displacement is the shortest distance. So displacement will be AB. That is your displacement. And again you will use the Pythagoras theorem here because it's a hypotenuse. So how do you go for it? Again 10 square plus 10 square, right? So answer is the same thing what we did over there because it's 10 10, right? So you know it's root of 200, so that will be how much? it will be again root 2 into 10, which will be 14.14 meters. Now if I ask you people what is the total distance, so what will be total distance in case it is being asked to you? So total distance will be 3.5 rounds, right? So 3 into the perimeter, right? So one round is how much? 40. So 40 into 3 plus 10, 10 more, so 20, right? So it is how much? 40 into 3 is 120 plus 20, so that comes out to be 120, 140 meter. I hope this is clear. Now, let's go through these questions. Which of the following is true for displacement? It cannot be 0. This is false because displacement can be 0. Its magnitude is greater than the distance traveled by the object. This is also false because its magnitude is either less than or equal to the distance traveled, right? Fuel used up in the vehicle depends on which of the following. Justify your answer. Fuel that we use in our vehicle depends upon the distance traveled or displacement. You can't say if you're going, let's say you're going from your home and going to school and then coming back to home. So your displacement becomes 0 here in this case, but the distance. You have traveled the distance, so you have consumed the fuel, right? The vehicle has consumed the fuel. So it depends upon the total distance traveled, correct? Because the engine is running and it is using the fuel. Uniform motion. When an object covers equal distances in equal interval of time, it is said to be in uniform motion. Here you can see covering equal distances in equal interval of time. When an object covers unequal distances in equal interval of time, then it is said to be non-uniform. So this definition is important here. Equal distance, equal interval. Unequal distance, equal interval. Okay. So here if you see, the distance traveled, same time period, but the distance traveled here is less. Here is 10 meter, here is 15 meters, so it's changing. So let's have a look at this video over here. What it is.
Uniform motion, when an object covers equal distances in equal intervals of time.
So here you see that the speed is same, right? 10 meter per second, 10 meter in 1 second it's covering 10 meter, but in this case, in every second the distance traveled is being changing, right? So that's the difference between uniform and non-uniform motion. Now what exactly is speed? The distance traveled by the object in unit time is referred to as the speed of the object. SI unit of speed is meter per second. There are other units also, centimeter per second and kilometer per hour. It's a scalar quantity and has magnitude only, no direction. So this speed is given by distance upon time. There is another thing called as average speed. Average doesn't mean that you take all the speeds divide by 2 odd number of what is given. Average speed is given by total distance traveled divided by the time interval during which the distance is covered. So average speed is total distance by total time taken. Let's see this question here. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. So what's the average speed? So average speed is given by total distance is 16 plus 16. Time is 4 plus 2, so what will it be? 32 by 6 meter per second, which is, if you cancel it out, 16 by 3 meter per second, or you can also say 5 1 by 3 or 5.33 meter per second. I hope this is clear, students. Let's move to next question. The odometer of a car reads 200 km at the start of a trip and 2400 km at the end of the trip. So odometer, if in the beginning it is showing 200, 2000, and at the end of the trip it is showing 2400, so how much is the distance traveled? So you subtract these two, right? So what is the distance traveled? Will be the final reading minus the initial reading, which is only 400 kilometer. If the trip took 8 hours, calculate the speed in kilometer per hour. Speed, you know the formula is what? Distance upon time. So that is given by 400 divided by 8. It is 50 kilometer per hour. Now we need to convert it into meter per second. So 50. Conversion is this. Kilometer is 1000. Hour you convert into seconds as this. You can also write it as 50 into 5 by 18 directly and cancel it out. So 925. So it's 125 by 9 meter per second. You divide it and get your answer. So what you will get? 9 ones are 9. 9 fours are 36, won't go. 3, 27. So 15 minus 7 is how much? 8. Decimal you put 0. 9 8s are 72. Again the same thing will come. So it is coming out it as 13.89 meter per second. Round it off and write like this. I hope this is clear. Let's move to the next question. Very important question, you can mark as average speed question. Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip, along the same route, there is less traffic and the average speed is 40 km per hour. What is the average speed for Abdul's trip? Now, how do we do this question is, so let's say school जा रहा है, so home से school जाएगा. Let's say it says home and then I'll mark it as school. Okay, so this is the distance he is traveling. So while driving to school, the speed is 20 km per hour, and while coming back, as there was less traffic, so it's increased, it is this much, right? Now let's say, let the distance from home to school, I'm assuming it as x kilometer, right? This is x kilometer. So what will be the total distance traveled by him? X he goes to school, x he comes back to home. So x plus x 2x kilometer, right? Now how do I get the total time? How do I get the total time? Because average speed is not 20 plus 40 by 2. Don't do that. You will get a wrong answer here. Total time formula you know is distance upon speed. Okay. So from home to school, time you take, plus school to home, time you take. Okay. So home to school will be distance x, speed is 20. School to home, distance x, speed is 40. What's the LCM? 40. So it will be 2x plus x, which is 3x by 40 hours is the total time. So now what's the formula of average speed? So how do we do average speed? Average speed is total distance by total time. So total distance is 2x, total time is 3x by 40. Clear? So 40 goes up, 2 into 40, x is cancels out, we have this, right? So what is this? It's 80 by 3 km per hour. Calculate what you will get here. You divide 80 by 3. So 3 2s are 6, 20, 3 6 are 18, again 2.20, तो 6 आता जाएगा. So I'll write it as 26.67 km per hour. You need to round it off, students, right? So I hope this is also clear. Average speed does not mean you take the two speeds and divide by 2, find their average. No, you have to get the total distance, get the total time, and then solve it. Okay. Now, what is average velocity of an object in a time interval is the change in the position or displacement divided by the time interval in which the change in position occurs. So average velocity is displacement or change in position by time interval. So average velocity, S यहाँ पे is not speed, students, it's displacement we represent by S by T. Now what is rate of change? To describe how fast or slow a change in a physical quantity happens, we use the idea of a rate of change. So the ratio of change in one quantity to the corresponding change in time is called as rate of change. So just a speed is distance upon time, velocity is displacement upon time. That is rate of change only because we are describing it with the help of time, how much it is changing with respect to time. Okay. Now, SI unit of average speed and average velocity is meter per second. Speed I already told you, meter per second. Generally we also use kilometer per hour also. You have seen in the previous questions. Now let's talk about this question. Sarang takes 50 seconds to swim from one end to the other end and back in the swimming pool 25 meter long. Find his average speed and average velocity within the time interval of 50 seconds. So Sarang takes 50 seconds to swim from one end to other. So there is a swimming pool. So this person is swimming, okay, in this pool, and it is how much long? It is 25 meter long. 50 seconds to swim from one end, let's say from here to here, and coming back. Total time, yeah. So total time is given. So total distance, how much it is? Total distance is 25 plus 25 because swimming pool is 25 meter long. So here it goes and comes back. So that's 50 meter. Okay, and time, total time taken is 50 seconds. So average speed 50 by 50, which is 1 meter per second. Okay, average velocity within the same time interval. So average velocity, what will it be? The displacement, if you see students here from A to B and he's coming back to A, so displacement will be 0, right? Opposite direction it is coming. So 0 by 50, so it's 0 meter per second. So if displacement 0, velocity will be 0, because direction is included over here. I hope this is clear. Now let's move to next question. During a family road trip, you drive 200 km north in 3 hours. Afterwards, you drive 200 km south in 2 hours. Find the average speed and average velocity for your entire trip. So let's draw it and see. So during a family trip, you drive 200 km. Now this distance is 200 km north. It's in 3 hours, right? Okay. Afterwards, you drive 200 km. This is the south direction. Up वापस south में आ गए 200 km, right? And that's in 2 hours. Okay. So average speed, let's calculate. What will be average speed? Average speed is total distance 200 plus 200. Total time 3 plus 2. So it is how much? 400 by 5, and which is 80 kilometer per hour, because 540 it's 8, right? So cancel करेंगे, it will be 80. Now average velocity, it will be total displacement, or only the displacement by total time. So displacement is how much? It is 200 upwards, north direction. South I'll take it as negative, right? And then time is 3 plus 2. So how much it will be? It will be 0 by 5, so 0 kilometer per hour. So I hope the concept.
I hope today's concept is clear to you students. So if you like the video, press the like button, subscribe to my channel and share it with your friends. Thank you. Bye till the next video.